Welcome to this presentation. In this video we will learn the different types of calculations involved in stoichiometry and mole concepts. These formulae are very important in stoichiometry and must be applied where required during calculations. For this question, first the number of moles of aluminium and chlorine are calculated using the formula. Then the mole ratio is compared to find the number of moles of chlorine. Chlorine is the limiting reagent because it is used first in the reaction. The mole ratio is compared again from the equation to find the number of moles of aluminium chloride. The mass of aluminium chloride can then be found by using the formula. By using the formula for percentage yield and rearranging it, the mass of aluminium chloride is obtained. For this question, 0.200 mole dm cubed mean that in 1000 cubic centimeter there are 0.200 moles of sodium hydroxide. Then by simple proportion the number of moles in 30 cubic centimeters can be found. Then by comparing the mole ratio from equation, the number of moles of sulfuric acid can be obtained. This number of moles of sulfuric acid is found in 25 cubic centimeters. Then by proportion, the number of moles in 1000 cubic centimeter is calculated, which is the concentration of sulfuric acid. For this question we see that 1 mole methane reacts with 2 moles oxygen. By the mole ratio, we can obtain the volume of oxygen. But from the mole ratio we see that oxygen is in excess. Therefore, methane is the limiting reagent. We just need to compare the number of moles for methane and carbon dioxide from the equation to obtain the volume of carbon dioxide. For this question, the elements and numbers are placed in a tabular form for easy view and easily follow the steps. Molecular formula is found by multiplying a number by the empirical formula. We just need to find the number and deduce the molecular formula. This question is based on a titration. First we find the number of moles of hydrochloric acid from its volume and concentration. From the equation, the number of moles of sodium hydroxide reacting with the hydrochloric acid can be deduced. This number of moles is found from the volume that has been titrated with the hydrochloric acid. By proportion, the concentration can be calculated. To find the volume of the stock solution used, we just use the formula and make the initial volume the subject of formula. In the last part, we just replace the values in the formula to obtain the dilution factor. For this redox titration, we just need to look at the number of moles of manganese reacting with iron solution in the reaction and calculate the number of moles required for the iron, solution. In this question, first we need to find the mass of the pure calcium carbonate, and from the mass, we can calculate the number of moles of calcium carbonate using the formula. By comparing the mole ratio using the balanced equation, we can deduce the number of moles of carbon dioxide, and using the formula for percentage yield, we can obtain the volume of carbon dioxide at room temperature and pressure.